Welcome to the channel. So today we are solving the question House Robber 3. So the question states that you are robbing a house, but these houses are arranged in a binary tree that you can't rob two directly connected houses. So if you rob this one, you can't rob this one. You have to skip this house and rob this one. But also you have to return the maximum amount of money the thieves can rob. So you can rob this one or this one and skip these two, but also you can skip this one and this one but drop these two, but that will be 5. The true maximum will be the 7. So you can see that there will be two cases. One case will be like you can rob this route, or other will be if you skip that. So this is the whole concept. There will be two cases, with node and without node. So we are using DFS. Start our DFS like this. There will be the two cases from the 7, and it will start, we will come to this node. So these will be none, so we are returning here 0 and 0, here also 0 and 0. So we now come to this. So there will be two conditions. So is it with node or without node? So so if we take with node, then there will be zeros will be at 0. 60 plus 0 will be 60. And without node, if we take without node, then there will be only 0. Then fs will here, and these will be also zeros. So now this will be what? So with node is 15, and so we can't take this one, so this will be 15 only. And so without this one it will be 60. So now we are going to the right side. Right will be 0 and 0, and these will also be 0 and 0, and this will also be 0 and 0. So this will turn 0. So with node it will be 2, and without node it will be 0. And now, and this will be 0 and 0, and without it will be, so with node it will be 9, and without it will be 2. So now it is this part. So if we include with node, so this will be like 7, and we won't add these one, so this will be 60, and we cannot add this one, so we have to add 2, so this will be 69. And also if we took without node, we can still take this 60. So we will add the 60 from the there, and this 9, which is also 69. So we will just compute the maximum. So the condition that we will make is that when we are computing with node, we need to add the node value plus left value, which is on the index 1, and plus right value. And without node we have multiple options, like we can include this 15, or we can just include this 60. So we will just add max left and max right, so we get maximum of these two. So the code for it is also pretty simple. It's a simple DFS but little changes. So we create a function DFS, and we are passing root through it, and if not root, then we can just return the 0 and 0. And now we are going to the left, calculating the left. So DFS root dot left, and similarly for the right, DFS. And now we are just returning with root and without root. We have to calculate these two, with root and without root. And we can just do with root will be root value plus left index 1, and we just add right 1. For without root, we are just adding max of left and max of right. So this is our complete solution, and we are just returning the max of the array. So DFS root, and you can check the solution, it's pretty efficient.